Good morning, Chitti. 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 I have heard this name somewhere. One movie came Robot. Have you seen Robot? Rajnikant movie. In that his robot name was Chitti. Yes. Chitti. Chalo, let's start. Okay. Let's start. So we'll start first of all with the revision. Okay. And then we'll revise everything, each and everything of the waves, what we have studied, right? Whether it is Doppler's effect, whether it is speed of the wave on string, whether it is open organ pipe, closed organ pipe. Okay, everything we'll learn. Then we will do some questions also, right? Okay, ready? Ho sab log? Are you people ready? Ready. Some new students also I'm seeing. Namrata, acha, you are not new. You come sometimes. Spandana, okay. User, who is this user? ये कैसा नाम है? User, change your name to real name. Urvik. Okay. User. Okay. So first of all, what is a wave? Okay. All of you ready now? Sab ready hai? Shall we start? Okay. For first of all, what is a wave? Wave hota kya hai? Why we study wave? What is the use of wave? So the wave that you have heard so much is radio wave, right? When TV was not there, when these communication systems were not there, radio was there. Okay. Marconi gave radio, right? So this radio, in radio we hear news, we hear, not now, we use mobile phone nowadays, but earlier people used to hear news and all these, all things were done by radio. There is a tower situated at some distance. From that tower, in the medium, some disturbance is traveled. Okay, that tower has some sort of instrument which gives the disturbance to the air particles. That disturbance is travel, and radio catches that disturbance, converts it into sound. Okay, that was the basic thing. Wait. Okay. So that was the basic thing. That was the first invention of waves. Okay. The invention, discovery of waves. Waves were already there, but discovery was there. Okay. Then later on came with this band of waves. Okay. Ultraviolet waves and so many waves. Right. Now this wave is something which is the disturbance that propagates, that travels in some space. That space can have some medium also. That space may not have some medium. Okay. So two categories came out. The waves which travel in a medium, the waves which travel without a medium. Okay. So can you people tell me the waves that does not need any medium? What are they called? Can you people tell me in the chat? The waves that does not need any medium to travel. I'm waiting. The wave that does not need any medium to travel is called electromagnetic wave. Correct, Namrata. That is called electromagnetic wave. Okay. And the wave that needs some medium to travel is called mechanical wave, right? Like example, the radio waves. Okay. EMW, yes, correct. Okay, so for that EMW, electromagnetic waves, we have a separate dedicated chapter. Okay. So what we are going to study in this chapter, or what we have studied in this chapter, mechanical waves, which need a medium to travel. So we'll talk everything on Earth. We'll not go out of Earth, because out of Earth, no medium, only electromagnetic waves. Okay. So these waves can propagate some energy from one point to another. That is a very good benefit of this wave, right? Because the particles vibrate, they travel. They travel what? Energy from one place to another. Okay. Without the transportation of medium, right? For example, there are 10 people, they are holding their hands, right? And what the first person got some stone. Okay. That stone is, let's say, energy. It has traveled, it is passed to other person, then passed to other person, then passed to other person. In that way, stone came to us without the disturbance in the line of those persons. Okay, what I'm telling is, it's just like if there are 10 persons or 10 people. Okay, 10 people like this, dot 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 dot, dot 10 people. So a stone is taken away from here. Okay, this is, let's say, energy. First this person hold it, then he traveled, transferred to this one, then he transferred to next. It happens simultaneously, and that stone finally came here. So stone traveled from this A point to B point, which is energy, without the disturbance in these persons. That is called energy transportation in case of waves. But these persons have moved a little bit, right? These persons, or this matter, persons are analogous to matter. This matter has moved a little bit, right? So that movement can be in two ways. Okay. Either they can go front, back, or they can go up, down, up, down. ये up down वाला कौन सा wave होता है? Can you people tell me? When particle go up, down, up, down, up, down, up, down, up, down. Which type of mechanical wave it is? Yes, correct, Suchendra. So it is transverse wave. All of you know, when particle go up, down means perpendicular to the velocity of the wave. Basically, this energy is transferred in this direction, but the particle is going up, down, up, down, up, down, like this, like this, like this, like this, like this, like this. Okay. So that's why we also study the relation of particle velocity to wave velocity. Yes or no? We study that na? I hope you remember. We will see that in further slides. Okay. Particle का अलग velocity है, wave का अलग velocity, right? And this left right wala, this is called longitudinal waves. Okay. Chalo. So example is there. The ripples on a pond, the sound we hear, visible light, radio and TV signals, these all are waves. Simple. Okay. Chalo. Let's go to the type of waves. So electromagnetic and mechanical. Electromagnetic wave, no medium required. No medium required. Okay. It is a combination of electric field and magnetic field, right? Like gamma rays, X-rays, microwaves, and light wave, okay, which comes from the sun to earth. Sun to earth, no medium, but it travels without medium also. Okay. Then second is mechanical waves. So this is going to be studied in this chapter. Mechanical waves, right, which needs a medium, like elastic waves and all. Okay. Chalo. Now, okay. Now, in mechanical waves, there can be two types of waves. One is transverse wave, one is longitudinal wave, depending on the particle vibration. Depending on the particle vibration. So transverse wave, basically, I think I told you a little bit wrong thing. Radio waves के बारे में मैंने गलत बता दिया, right? Radio waves, I told it needs a medium. Radio waves does not need a medium. Radio wave is a electromagnetic wave. EMW. I think I gave one sentence, right? So radio wave is a electromagnetic wave. Okay, chalo. So transverse wave in which particle goes up down up down up down, and wave goes in the progressive way like this. Wave will go in this way, like you took one rope, flicked it. Okay, so the wave will travel in front, but basically particles are going up down like this. So this is called transverse wave. Vibration of particle is in perpendicular direction to the motion of wave, right? Second is longitudinal. Longitudinal means the particle moves not up down, right left, okay, in the line of motion. Okay, so wave motion is in this direction. The vibration is also in the same direction only, front to back, front to back, front to back, right? Chalo, next. You can read these things later. Okay, when the class is over, you take a reading of these all things. Okay, everything will be revised then, right? Chalo, let's come to wavelength. Some important points we will see. So what is wavelength? Wave ka length, let's say I took one sinusoidal wave like this. Okay, let's extend it further, because you will question me, sir, why you take only one time period, take more. Okay, so this is the wave, right? This wave repeats after a particular interval, right? So I can see this section, then this section again repeats, then again it will repeat, then again it will repeat. So this repeating section is called wavelength. Okay, this is one wavelength and denoted by lambda, right? So this is called wavelength. Now if I come across time period is the time required for the wave to move one wavelength. What it is? Time required by the wave to move one wavelength. Wait, YouTube पे check करते हैं. I think everything is fine. Okay. Good morning, Abhay. Chalo. So time period is what? Time required by the wave to move lambda. Lambda means one wavelength. Okay, that is time period, right? Time period, we can write T is equal to 2 pi over omega. Okay, time period is 2 pi over omega. Or we can write normally we write distance upon velocity in a time. So lambda upon velocity. What will be the velocity? V of the wave. Okay, this also can be the time period, right? Amplitude is the maximum particle displacement. Remember, amplitude is maximum particle displacement. Okay, maximum particle displacement. Are you hearing this chapter as a story? Are you people not sleeping? Are you people there? सब लोग हैं? It feels very awkward sometimes. I'm speaking. Nobody is there. All are busy in their works. Yes. Are you people there? Can you confirm me with a tick and thumbs up? Great. Okay. Thanks. Chalo. Now I'm feeling better. Somebody is listening. Okay. So what is amplitude? Maximum particle displacement. If I talk about amplitude, then amplitude in this wave I can see if the particle is here, it has a maximum displacement of this much only. So this is amplitude. Simple. Okay. It's a why you have not taken downside? Yes, you can take downside also. This is also amplitude. No problem. Okay. Chalo. Next is angular frequency. So angular frequency is omega, and this omega is equal to 2 pi upon time period. Angular frequency. Okay. Angular frequency. Right. Just a second. Okay, it is angular frequency, or you can also write it as 2 pi f. F is 1 by t, na? Frequency is 1 by time period. So you can write this also. I hope you understood. Yes, let's move forward. Let's come to phase. What is phase? Phase is chehra, you know? Oh, sir. This phase or this phase? Not this phase. This wala phase. Okay, so what is phase? Phase, if I explain you with respect to a mean position, basically the particle, this is the, let's say, mean position. I am considering transverse wave. Particle goes up, comes down. This is one complete oscillation, right? Goes up, comes down, and goes up. If particle starts from this mean position, this is called mean. And these two positions, which are maximum, are called extremes. Extremes. Okay. Extremes. So if particle starts from the center position or mean position, then phase is called zero. Then phase is zero. So phase is a quantity which contains all the information related to starting of the particle. Okay. For example, if I write that a particle is having particle motion, we have already studied in SHM, right? So it follows a sine omega t. If I have written like this, nothing I have written more, that means particle is starting from mean position. If I have written plus 30 or plus pi by 6, radians में लिखेंगे ना, plus pi by 6 means the particle is not starting from mean. Particle is starting from some distance from the mean position. How much is the distance? How much is the distance? It is the total is, this total is called pi by 2. Pi by 2 or pi? Total is pi by 2 or pi? If I talk about the phase between extreme and mean position, circle bhul gaye? Have you forgot the circle? If a particle goes in a circular motion, and if I take shadow, if I put a source here, I explained you very nicely. Huh? If I put the source here, light is coming. Particle is started from here. It is going in this direction. If I take a wall, on that wall, if I take the shadow, so this is called mean position. This particle will go to somewhat here, maximum, to somewhat here, maximum. These are called extremes, right? So particle देखो यहाँ से चालू हुआ 0 degree, then it go like this. So this is 90 degree, means pi by 2. So from mean to extreme it is pi by 2, not pi. Got it? Yes. Okay, thanks for the help, Karthik and Suchindra. So it is pi by 2. So pi by 6 से start हुआ, that means if particle is somewhat here. Okay, see the circle? Particle is somewhat here, and the angle measuring from this mean is pi by 6. This is called phase. और इसका shadow ले लेंगे. If we take the shadow, then we'll get some distance also related to pi by 6. Okay, that distance can be easily found. है ना? This is amplitude. This is amplitude. Make the triangle. Amplitude हो गया, और क्या बचा? और कुछ नहीं बचा. So I can write this as a cos pi by 6 sin pi by 6. So this is what? A sin pi by 6. Simple, right? So in this way we can find. So phase is from where the particle is starting. Okay, simple. अच्छा, एक नेगेटिव फेज इज देयर. ये तो पॉजिटिव था. नेगेटिव फेज है मींस समवॉट डाउनसाइड इट इज स्टार्टिंग, बिकॉज एंगल इन क्लॉकवाइज डायरेक्शन विल टेक अस नेगेटिव. आई होप यू अंडरस्टूड. चले आगे. एंगुलर वेव नंबर. ओके, दिस k is called angular wave number. Okay, when we'll see the equation of the particle, there will be some omega t minus kx, so that k is called angular wave number. Okay, what else to be told here? K is what? K is 2 pi upon lambda. And sometimes wave number is also, this is angular. Sometimes wave number is also asked. Wave number. So this is not angular. So 2 pi हो जाएगा गायब. So k will be equal to 1 by lambda. Simple. Okay. चलो. Next. Relation between particle velocity and wave velocity. Important point. Okay. So particle is executing SHM up and down. Wave is moving in front in case of transverse. So particle ka velocity, let's say particle velocity is Vp. Not particle velocity is not Vp. Particle velocity will be dy by dt. Okay. This is because particle is going up, down, up, down, up, down, up, down. So dy by dt is particle velocity. Particle ka velocity. And Vp is wave velocity. Wave velocity. Okay. So this is the formula. If you read in words, it is written particle velocity at a given position and time is equal to negative of the product of wave velocity. So I'm writing this statement here. Negative of the product of wave velocity with slope of the wave. So slope of the wave is dy by dx. This is called particle velocity, dy by dt. Same formula. This one. Okay, if you take this Vp here, if you multiply, you will get the same formula. Okay, so this relation you have to remember. It can be asked. Okay, not in this form. They will give you the particle velocity and they will ask you the wave velocity at that point. Okay, so it can come like that. So you have to remember this formula. Okay, I hope you have the idea that particle is executing SHM, wave is moving front. Okay. So let's analyze something about this wave. Okay. So here are three things: phase, wavelength, and time period. Okay. Phase, wavelength, and time period. If particle starts from the origin, the phase is 0. Origin means mean position. Phase is 0. Okay. Wavelength will be 0, no wavelength here, and time period is also 0 because it is starting, t equals to 0. When it come across some pi by 2, okay, that means it has completed the circle, 1/4 circle. Okay, so pi by 2 is the phase difference. Wavelength is total is lambda, so 1/4 of lambda will be lambda by 4. Then time period is t by 4. Simple. Then we will go to phase difference of pi, lambda by 2, half of the length it has traveled of the wavelength, and time is also half. Similarly, these the parameters, and similarly these, then so on. It can be extended. Okay, so there are two differences. One is called path difference, and one is called phase difference. Phase difference. Okay, so always remember path difference or phase difference का formula. Okay, path difference or phase difference का formula. Path difference, if I write delta phi, this is path difference, is equal to 2 pi by lambda into phase difference. Okay, remember this. Delta x is called phase difference, which I'll just mark it like this. Delta x is phase difference, and this is path difference. Okay. Sometimes this delta x is also written delta lambda. Okay, path difference. Here it is written, na? That's why I'm telling. I hope you understood. Shall we move? Sure. So next, general equation of wave. So general equation of wave means all the waves in this universe will follow this equation, this differential form of equation. If you want to check that the given wave is a general wave equation or not, then you can just differentiate it. The y component you can differentiate 2 times with respect to t. Okay, if this type of relation is formed, then it is a wave equation. In the previous classes, in the wave, when the wave revision was going on, I have given you one question on this also. So you can go in the drive section and you can open the waves wala if you want to do a question on this one. Okay, you can open the waves notes and you can do the question from there. Okay, so here time is less since we have to revise everything. I cannot include questions more. Okay, now speed of wave is given by the coefficient of t and x. Okay, so the equation of wave will be somewhat like this. Y is equal to a sine omega t minus kx. Okay, acha, this equation is when the particle starts from mean or extreme. I have told this also. We have derived for 2 relations. Do you remember? When particle starts from mean, some equation was there. When particle starts from extreme, some equation was there. So if the equation is in sine form, the particle starts from mean or extreme. Tell me in the chat. Forgot? Really? Oh my God. You people can hear me, na? Anyone? अरे साइन का वेव कहां से स्टार्ट होता है? Origin से, like this. What happened? Forgot? Ah, Karthik, correct. What about others? Oh my God, I'm so disappointed. I gave so much of energy there. Chalo, no problem. So listen, साइन में अगर फॉर्म आए इक्वेशन का, then remember the sine curve. अब ऐसे ही बताना पड़ेगा, right? We have derived fully there in those previous classes. Okay, so if sine का आता है, that means you remember sine curve. Sine curve starts from origin. That means this is mean. So particle is starting from mean in this case. If the equation is given somewhat like this, y is cos of omega t minus kx, then particle is starting from extreme. Sir, what if particle is starting from between extreme and mean? That also I've told that. If particle is starting from somewhere between in mean and extreme, then some phi will be added here. Plus minus phi. Some phase difference will be added, na? Okay. So here it is telling what is wave velocity. Wave velocity is coefficient of t. Coefficient of t is omega. So wave velocity is omega upon coefficient of x. Coefficient of x is minus k or k, right? Omega t plus kx. Let's take omega t plus kx in both cases. Okay, right? So wave velocity is v is equal to omega by k. Remember this, right? Also, this can be modified. इसको modify भी कर सकते हैं if you put the value of omega as 2 pi by t. 2 pi by t है ना, that's modification can also be done. Okay, 2 pi by t, 2 pi by k is lambda. हाँ ठीक है. Next, let's do a quick question. Okay, you have to answer this one. Try, take 1 minute only. Take 1 minute only. Madhavi Chatti, correct. Madhavi, what are you asking? Difference between particle and wave velocity. कैसे बताया जाए? Madhavi threw a stone in water. Okay, so something will go where you have thrown the stone. Na, the waves come. Na, some waves are formed which go this far. So is water going far? No. If you put a leaf in the river and if you throw a stone, the wave will not transport the leaf. Leaf will go up and down, but some wave will be going in front. So when leaf goes up and down, that is called particle velocity. When that something is traveling to some distance, the wave is traveling to some distance, that is called wave velocity. Okay, if you take a rope and if you flick it, the rope ka particles are not going in front, right? But something is going na in front. Ek wave sa dikhta hai. A trough or a crest is going in front. Trough crest means that bulge part that goes in front, that is wave velocity. And particle are going up and down, that is particle velocity. Any answers? Deepak, you got the correct answer, but it is asking path difference. It is asking path difference. You only found path, that is lambda. Pi by 3, Nisar, how? Pi by 3 path difference कैसे आएगा? ये आंसर सही दे दो, my life will be blessed. Deepak, I think your answer is absolutely correct now. Okay, my life is blessed. Thanks. Any more answers? I'll not spare much time on it, okay? Because more things are there to revise, important things, okay? Chalo. So see this question. A progressive wave of frequency 500 hertz is traveling with a velocity of 360 meter per second. So wave velocity is 360 meters per second. And wave frequency is f is equal to 500. Okay. It is wave frequency, not angular wave frequency. Okay. How far apart are 2 points? 60 degree out of phase. So phase difference is also given. Difference 60 degree, pi by 3. Now it is asking how far apart are 2 points. Means let's say this is the wave. Okay. This point and this point. Let's say these both points have a phase difference of pi by 3, 60 degrees. So it is asking what is the path difference between them. Okay. So to calculate path difference, what is path difference or what is phase difference relation with path difference? Delta phi is equal to 2 pi by lambda into path difference. This is the relation. We have to calculate this path difference. That means we have to calculate delta phi into lambda upon 2 pi. Simple. Only this thing we have to do. So basically we have to calculate only lambda. Phase difference is given. Pi तो आता है. Okay. So lambda calculate करने के लिए lambda is what? Distance. Distance is velocity into time. Simple. Velocity into time is time period. More answers. Correct, Nisarja. Very good. So velocity into time. What is velocity? Velocity is 360. Time. What is time? Arey sir, time is not given. No problem. Frequency is given. Time period is equal to 1 by f. So we can put 1 by 500. So lambda is 0.72 meters. Simple. Lambda आ गया. Now we can put the values. So delta x, which is path difference, is equal to phase difference pi by 3 into 2 pi into lambda 0.72. Cancel. 6 1s are 6, 6 2s are 12. है ना? Meters. Okay. Path difference. If you understood, give a quick tick. अगर नहीं समझ आया, give a cross so I can explain it again. If you understood, give a quick tick so that we'll move to next topic. Tick or thumbs up. More ticks I want. Deepak understood, I know that. Others, what about others? सबको आना चाहिए. Important chapter. Okay. Force yourself to do the questions. Suchindra, Sonu, okay. What about others? Vidya, Divya. Analogous लग रहा है. Suchindra, understood, I think. Chetan, Joyce, Karthik, Arun, Likit, Pallavi, Purvik. Getting na? Can I assume you are getting? Let us assume. Okay? Chalo. Let us move to the next question. Okay, Chetan. Not question. Equation. Equation I have already told you. Y is equal to A sine omega t. What I'm writing? A sine omega t plus kx or minus kx. Anything. Depends on the question. Right? So this omega can be written as 2 pi by t. So it is written here also in the same manner, 2 pi by t. And this k can be written as 2 pi by lambda. So it is written, and 2 pi is taken common. Okay, same thing. And if it is not starting from mean position, then plus minus phi. So plus minus phi is also added here. Agar sine ki jagah cos hai, that means it is starting from extreme. Simple. Next, speed of longitudinal waves. Question is very famous from this topic. Speed of longitudinal wave. So speed of longitudinal wave in case of solids, it is Young's modulus upon rho. Okay, that is the density of the material in which it is traveling. And in liquid, bulk modulus. In liquid we have bulk modulus now because volume is there, right? So bulk modulus upon rho, right? You have to remember these formulas. Next. Oops, sorry. Okay, next is interference of waves. Dekho, there are two things. Remember, one is interference, one is stationary waves. So much confusion is there between students, right? Interference, stationary. Interference, stationary. What happens in interference? Interference में क्या होता है? Waves are traveling in same direction. What? Waves are traveling in same direction. Okay, इन दोनों का addition of amplitudes is interference. But the condition is very simple here. Here you can read in the statement also. When two waves of equal frequency, the frequency should be equal. That means omega should be equal. तो equation कैसा दिखेगा? A sin omega t और B sin omega t, A1 sin omega t और A2 sin omega t. the frequency should be same. Okay, and the amplitudes should be comparable. For example, one is having an amplitude of 4, second is having an amplitude of 3, so they are comparable, na? Not much difference is there. Okay, third thing is important is they are traveling in same direction. Okay, they are traveling in same direction. Okay, so these three things are very mandatory for interference. Interference में क्या होता है? Interference same direction travel. Same direction travel. Later on in the stationary waves में क्या होता है? Opposite direction में travel होता है. Okay, चलो. So when these two waves, let's say this is A1, this is A2, they are having nearly same amplitudes. Okay, but they are having some phase difference. See, the starting point of upper wave is 0, means mean से start हो रहा है. The starting point of second wave is not 0, having some phase. It is starting with some phase. Okay, so how we will interfere them? First, find the phase difference. What do you have to find? Phase difference. Let's say there are two equations. I'm encircling. These are the two equations. Omega पहले check करेंगे. Omega is same. Very nice. Now we will check plus में कितना phi add हो रहा है. Okay, so in first one no phi is added, means it is starting from mean position. In second wala phi is added, not starting from mean position. What is the phase difference between these two? Phi minus 0 is phi. Simple. Let's say phi is 60 degrees. Initially 0. In the first case it is 0. 60 minus 0 is 60 degree. The phase difference is 60 degree. So if you want to calculate amplitude, what you will do? See here downside. Amplitude resultant is equal to under root first का amplitude square, second का amplitude square, plus 2 into first amplitude, second amplitude into the phase difference. Okay, cos of phi minus 0. Simple. This is the formula to calculate amplitude. I hope you understood, right? Intensity का क्या फंडा होता है? This is the calculation of amplitude. Intensity का फंडा is intensity ना, it is directly proportional to amplitude square. It is directly proportional to amplitude square. So if I square both sides in this equation, I'll get A resultant square, A1 square, A2 square, 2A1 A2 cos phi. So AR square I can write intensity resultant because square का proportional. I1 I2 plus 2 root of I1 root of I2 cos phi. Okay, the same formula which is written here. Okay, so this formulas you have to remember, right? Chalo, let's move to next. Now there are two types of interferences. Okay, constructive and destructive. Constructive mein you will get maximum intensity. For example, there is one wave, there is another wave. This wave is having like this, means iska dekho maximum is at this point. At this point only, the second wave is also having the maximum. So basically they are forming constructive, means they both will add. A1 will add to A2 directly. So maximum value will come. This is called constructive interference. If I write the formula of resultant amplitude, it is under root of A1 square plus A2 square plus 2A1 A2 cos of phi. I want maximum. Constructor mein you will get maximum amplitude, right? So for maximizing, I need to put this cos phi as 1. I need to put this cos phi as 1. Cos phi is 1 when phi is equal to pi or 0 or pi, 0, pi, 2 pi, n pi. So when the phase difference between the two particles is 0 pi, 2 pi, you will get a constructive interference. Okay. Pi by 2. Suchindra, pi by 2. Are you sure? it is we can say not pi exactly. Pi नहीं होगा. Pi will not be there. I have written wrong pi. 0, 2 pi, 4 pi, n pi, where n is twice of any number, or we can just write 2n pi. Okay, even होगा. Cos 0 का cos 1 कब होता है? When we have 0, when we have pi. It is not sine. Okay, Suchinta, I hope you understood. So this value will be maximum. Amplitude will be maximum when you have cos as 1. और cos 1 कब होता है? 0 पर. Okay, it is not 1 at pi, it is minus 1 at pi. Okay, so वो किस में आ जाएगा? That we'll see, right? Okay, so if I put this cos phi as 1, I'll get a resultant as a1 plus a2 का whole square under root. Since it will become a1 square plus a2 square plus 2a1 a2, which is a1 plus a2 का whole square, then you will get resultant as a1 plus a2, which is the formula written here also. Okay, similarly, if I go with intensity, the intensity of formula will be this one. In place of a1 and a2, I have written under root i1 under root i2. Okay, for destructive means least frequency. What? Least frequency. So for least, so not frequency, least amplitude. For least amplitude means सबको zero हो जाए. क्या हो जाए? Zero हो जाए. No amplitude should be there. Destructive में देखना, the waves will be, if I draw two types of waves, one wave is like this, the other wave is just opposite. Just opposite. Then it will form destruction. ऊपर वाला amplitude, नीचे वाला amplitude minus का 0. So it will happen when the phase difference between them is pi by 2, 3 pi by 2, 5 pi by 2, like that. Okay, sorry, phase difference is odd multiples. Part difference I was telling. Phase difference is pi, 2 pi, 3 pi, 5 pi, 7 pi, like that. Okay, so the phase difference should be in this form, like this. Phase difference and path difference is very simple, right? You know na? Phase difference is equal to 2 pi by lambda path difference. Simple. Okay. Okay. So minimum intensity can be a1 minus a2, and amplitude can be a1 minus a2, and intensity can be i1 under root i1 minus under root i2 ka whole square. Okay. So in this equation, for destructive, you need cos phi as minus 1. Okay. This is for constructive interference. This is for destructive interference. Minus 1. Minus 1 कब आता है? Pi, 3 pi, 5 pi. Okay. So read this slide once. Okay. You will get the idea very nicely. Next. Let's go to velocity of transverse wave. Time is very less. Velocity of transverse wave. Just remember which formula? This one. Okay. Velocity of transverse wave is under root t by m. This is the velocity on a string, okay, which is having tension of t, and mass per unit length. Mass per unit length is equal to capital M by L. Capital M is total mass, L is length of the string, right? Next. Stationary waves. So stationary waves में waves traveling, या फिर लिख सकते हैं सुपरपोजिशन of waves traveling in opposite direction. Okay, opposite direction. Opposite direction. Okay, so transverse wave कैसे बनता है? When one wave traveled, some wall is there, it reflected and came back just opposite, so that is standing waves. Okay, or stationary wave. So in stationary waves there are two cases. Okay, first is the transverse stationary waves, which is on a string. Second case is inside the organ pipe, which is longitudinal stationary wave. Okay, so transverse wave mein I'll tell you the trick to remember what is first overtone, what is second overtone. This is confusion is there. I have already told it, I'm revising it again. So this is the fundamental harmonic. Fundamental means smallest loop that can be formed between two ends. What? Smallest loop. So loop can be one starting from आधा loop तो बनता नहीं है. Okay. Remember, when there is end, then it is closing. What is end and closing? This is the end. This is the end. What are these? End. End. If there is end, then this strings or this wave will close like that. Yes, correct, Karthik. Okay. If end is there, then it is closing. If it is open, then it is means if the end is open, we will see in case of organ pipe. If end is open, you will have antinode. And on closing, you have node. What is antinode? What is node? This in Hindi we call gaant. Okay. You take one rope and you tie a knot, that thing. Okay. So this is called node. This is called node. And this is called this center part. This is called antinode. Okay. This is called antinode. So fundamental mein you have only one loop. Second harmonic, fundamental is also called first harmonic. Okay. Second harmonic mein you have two loops. Third harmonic you have three loops. Fourth harmonic 4 and so on. What is if I come across, okay. So this is on the string, right? In fundamental you have the path as this. The total is called like this now. This is called lambda. Yes, for stationary waves, it will be completed like this. This whole is lambda. So आधा कितना होगा? Lambda by 2. That's why lambda by 2 is equal to length. Okay. So इसमें से सब कुछ आ जाएगा. You will get lambda is equal to 2L. And then if you want to calculate the time period is lambda, which is the distance divided by velocity. Lambda you can put 2L and velocity, so you'll get relation of time period with 2L by V. Calculations can be done. Okay. Similarly, second harmonic mein you have the full wave, which is lambda. That's why lambda is equal to L, and so on. Simple. If I come across organ pipes mein what I told, if closed, then it is node. If open, side is open, then it is antinode. Okay. So see here, either closed hai, then it is node, and here it is antinode, open side pe. Okay. So this is how much part of the wave. Again, I am drawing the wave, stationary wave. This full is lambda. And how much part is shown? Only this much part is shown in fundamental. Kitna part dikhaya hai? Only this much part. This part is lambda by 4. Okay, total is lambda, so I can divide in 4 parts. This is lambda by 4. That's why in first case L, length of the organ pipe, is lambda by 4. Okay, from here you can get lambda and so on. For calculations you can take. Okay, this is fundamental. A fundamental ke baad the full loop cannot be formed because one side is open. Pura loop to kabhi banega nahi. So therefore it will have 1.5 loop in the second step. And this is called first overtone. Overtone. See the word overtone. Tone matlab loop. आगे लगा है first, means one loop is there, and over to that loop lambda by 4 is also there. Overtone means एक loop complete and then there is some extra over. Okay, first overtone means one loop is there, some extra loop is there. Extra is lambda by 4. So lambda by 2, this is how much? Lambda by 2, and this is lambda by 4. So it is how much? 3 lambda by कितना हुआ ये? 3 lambda by 4. 3 lambda by 4. Yes. So L is equal to 3 lambda by 4 in second case, and so on the calculations. If I come across second overtone, so see the word second overtone. Second overtone means 2 loops. 2 loops, and over is there. Over means plus extra. Extra is lambda by 4. So 2 loops plus extra. 2 loops is lambda. Extra is lambda by 4. So it is 5 lambda by 4. Further calculations. If I come across closed organ pipe or open organ pipe, both sides, then it will be antinodes both sides. Okay. So this is lambda by 4. This is lambda by 4. So the length of open pipe is how much? 2 lambda by 4, that is lambda by 2 is equal to L. If I come across first overtone, again, first overtone means one loop, and over means some extra. So extra is, this is extra, this is extra, as both sides are. Okay, if one side was open, then only one extra. So this is lambda by 2. This is lambda by 4. This is lambda by 4. Okay, lambda by 2, lambda by 4. So kitna hua ye? This is total is lambda. Okay, so this is lambda. 2 lambda by lambda, 2 lambda by 2 is lambda only. And similarly for the second overtone, 2 loops plus some extra. I hope you understood. We will go to the next thing. Time is less, little bit fast I'm going. Okay, come along with me. Beats. What is beats? Beats, it's not like the DJ beats. Okay, not that one. You can compare little bit, you can compare. Okay, beats are basically the sound which increases and decreases and increases and decreases. That is called beats. Like this is called beats. Same thing is happening here. Increasing, decreasing, increasing, decreasing. Why this happens? Due to interference of two waves, which have very, very slight difference between their frequency. So what it is? Slight difference between frequency. If slight difference between frequencies, then it will have some difference in frequencies, f1 minus f2. This is called beat frequency. Only this formula you have to remember. That's it. This is called beat frequency. Acha, sometimes time period is given. So can you reciprocate? Reciprocate kar lenge. 1 upon T1 minus 1 upon T2 is equal to 1 upon T. Right? Chalo, Doppler's effect, quickly we'll see. What is Doppler's effect? So Doppler's effect mein, there can be 4 cases. Okay, there are 2 things. First is called observer. Second is called source. Observer, source. 4 cases. First, second, third, fourth. 4 cases क्या बन सकते हैं? 2 cases in coming together, 2 cases in going apart. So first 2 cases of coming close. Other 2 cases can going apart. Okay, coming close, going apart. Acha, coming close mein first case is when source moving towards observer and vice versa. What is vice versa? या तो source is coming towards observer or observer is going towards source. Anything. Okay, in both cases are same na. Observer पे बैठ के देखो, if you sit on observer and see, the source will be coming towards you or you will be going towards the source, means distance is decreasing. This can be the first case. In this case, the frequency, let's say source is emitting f. फ्रीक्वेंसी, फ्रीक्वेंसी। सोर्स क्या है? लेट्स से इट इज स्पीकर, सम स्पीकर, ओके, बोट का स्पीकर, बोट कंपनी का स्पीकर, इट इज प्लेइंग सम म्यूजिक, ओके. So this source is having a original frequency of f, but when this will come closer to you, so you will hear a frequency higher or lower. Tell me in the chat quickly. Frequency you will hear is higher or lower if source is coming towards you or you are going towards the source. जो frequency सुनाई देगा वो ज्यादा सुनाई देगा या कम, high और low? अरुण कार्तिक, ओके, हाई सुनाई देगा, वेरी नाइस. So when they are coming close, high frequency will be heard. So if I say apparent frequency, this is called apparent. क्या कहते हैं इसको? Apparent. Apparent means नकली, fake. It is not there, but वो सुनाई दे रहा है due to some arrangements. Okay, this is apparent is fake, but we hear that only, right? So apparent frequency will be greater than original frequency. If I come to second case in this one, if both are moving towards each other, when both moving towards each other, okay, then also apparent frequency will be greater than f. Ultimately they are coming close. Coming close mein you will get these both cases same only, okay. Acha sir, what is the formula? We will see one centralized formula, okay. I always teach that. Third is when observer or source is going apart, when observer or source going away, and fourth case is when both going away, okay. Both cases mein when they are away, apparent frequency is less than original frequency, okay. Now what is the formula? तो यहां देख लो formula. Apparent, fake frequency. अच्छा, there is one common what we can call case. If you are sitting on the source पे बैठे हो, if you are sitting on the source, you will hear original frequency because you are sitting on the source only. You are not going or not coming towards the source, right? Okay. Formula is apparent frequency का formula is the original frequency multiply. सबसे पहले लिखो बड़ा सा bracket, okay. Then you write speed of sound c. ऊपर लिखो c, नीचे लिखो c. लिख दिया. ऊपर लिखो प्लस माइनस, नीचे लिखो माइनस प्लस. इसका मतलब प्लस ऊपर आएगा तो नीचे माइनस आएगा, नीचे प्लस आएगा तो ऊपर माइनस आएगा, लाइक दैट, ओके. सी प्लस माइनस, सी माइनस प्लस. अब हम याद करेंगे ऑपरेटिंग सिस्टम को, ओएस को. तो ओ आएगा न्यूमरेटर में, डिनोमिनेटर में आएगा एस. ओ इज व्हाट? ऑब्जर्वर. एस इज व्हाट? सोर्स. सो वेलोसिटी ऑफ ऑब्जर्वर, वेलोसिटी ऑफ सोर्स. दिस इज द फॉर्मूला. सर हाउ विल यूज इट? वेरी सिंपल. फर्स्ट केस में लेट्स यूज इट. फर्स्ट केस में when source is moving towards observer and observer also moving towards the source, okay, anyone is moving, okay, so what we will use? ऊपर प्लस आ जाएगा because the frequency is increasing. If frequency is increasing, numerator should be increased, denominator should be decreased. For increasing numerator, something should be added in numerator, that is plus will come, and denominator minus आएगा. तो इसके लिए फॉर्मूला क्या बनेगा? कमिंग क्लोज के लिए एफ ए इज इक्वल टू एफ सी प्लस वी नॉट सी माइनस वी एस. बन गया, ओके. नाउ व्हाट इज द ऑब्जर्वर वेलोसिटी यू कैन पुट, व्हाट इज द सोर्स वेलोसिटी यू कैन पुट. इन द सेकंड केस, अगर सेकंड केस की बात करें, गोइंग अपार्ट, सो एफ ए इज इक्वल टू एफ अपार्ट, दूर जा रहे हैं, दैट मीन्स apparent frequency, this apparent frequency heard will be less. लेस है तो न्यूमरेटर में क्या आएगा? माइनस, डिनोमिनेटर में क्या आएगा? प्लस. सर व्हाट इफ ऑब्जर्वर इज स्टिल? हाँ तो जीरो आ जाएगा, दिस विल बी जीरो. Sir, what if source is still? Source is zero. Sir, what is velocity of sound is zero? Not possible. Okay. Chalo. This is done. Now for your practice, time is already up. 3 minutes bacha hai. Chalo, no problem. So for your practice, I am giving you some questions attached with this PDF. Okay. When both sources. So I'm just putting up the answers here. This is homework. Okay. Since the time is not there, we cannot do it. So it is 200%. Iska answer 200%. Next, this one is answer is bet wala na 47.47. This is a good question, huh? You will get the feel, real life feel of what bats do. Bat क्या करते हैं? They emit ultrasonic vibrations, ultrasonic frequency everywhere, है ना? When they are moving towards something, they emit ultrasonic. अगर वहां से रिटर्न आता है frequency higher, that means गड़बड़ है. That source is coming towards him, or he is going towards a stationary source. So agar if he have sent 40 kilohertz frequency and if 42 came, he will say, oh, some gadwad, some source is there, I'll turn. Then he moves, then he turns. If frequency comes less, then he will say, okay, there is something apart from me, but it is going away. There is no barrier. So in this way, bats sense. Okay, they don't have eyes. What is sees? Arey, Karthik. लिखना पड़ेगा, में लिखना पड़ेगा, अदरवाइज. कार्तिक पढ़ो क्या लिखा है. स्पीड ऑफ साउंड. स्पीड ऑफ साउंड कितना लेते हैं नॉर्मली? 330 meters per second. Depends on the question. If question में कुछ नहीं दिया, you take 330. If question में दिया, then take that one. Got it, Karthik? Okay, C is not speed of light. Speed of light मत समझना, right? There's a speed of sound. Third question, इसका आंसर a particle. Find the value of a square ना. A square is equal to 175. ऑप्शन ए. ठीक, इसका आंसर 11 hertz. ऑप्शन ए. I'll write it here also, option A. Please do these questions, huh? Just after the class, after attending all the classes. Answer iska, next one, option A. Option A. And हो गया सारा क्या? Yes. Okay, I hope you understood everything. If there is doubt, you can ask me. Otherwise, complete NPS and then you can go. I have tried to cover everything. Sara cover ho gaya hai. Everything is done. Okay, of waves. Nothing will come out of this, right? There are some topics like sonometer and all. So those you can read, take a reading. Those are not very important topics. Okay, you can read them from the drive. You have LN booklet. You can read from there if you want, if you are interested in doing that. So how many questions I gave you? I think I gave you 5 questions now. Okay, do these questions. If you have any doubt, you can ask me on WhatsApp, or you can on WhatsApp only you ask, not on Telegram. Complete NPS. Quick. Important. Okay, Nisarja, bye. YouTube wala people, any question? No question? Okay, so ending the class here, right? We will meet tomorrow. Okay, bye and have a good day.